You cut your calories, you skipped breakfast, you ran for 40 minutes, and your belly got softer, not smaller. That is not a failure of willpower. It's a biological trap your body designed to survive starvation. Visceral fat is not the same as the fat on your arms or legs. It is chemically and biologically distinct, and the difference is not cosmetic. Research shows that visceral adipose tissue, the fat wrapped around your liver, pancreas, and intestines, is densely packed with glucocorticoid receptors. Clinical estimates put the density at roughly 4 times what you find in subcutaneous fat, though the exact multiplier varies by study population and measurement method. The directional finding is consistent across the literature. Think of these receptors like signal antennas. The rest of your body might barely register a low-level stress signal, but your visceral fat picks it up, amplifies it, and responds. It is biologically wired to be a magnet for cortisol. This creates a mechanical problem that a simple calorie deficit cannot solve. Cortisol is a hormone, and it does not care how many calories you ate today. The same circulating cortisol level hits your belly fat 4 times harder than it hits your thigh. That is the first layer of the trap. The receptors make the signal loud, but the fat tissue did not stop it listening. It learned to manufacture the signal itself. Here's where the biology gets unsettling. Visceral adipose tissue highly expresses an enzyme called 11-beta-HSD1. This enzyme takes inactive cortisone, circulating in your blood, and converts it into active cortisol, right there, inside the fat tissue. Your visceral fat does not need your adrenal glands to produce cortisol. It can make its own locally and on demand. The fat is not just a storage depot. It is an endocrine organ with a degree of independence. When cortisol binds to those receptors on your visceral fat cells, it triggers 2 things. First, it signals those cells to expand and store more energy. Second, it stimulates the fat tissue itself to release inflammatory signals, specifically cytokines, like interleukin-6. Those inflammatory signals travel to your brain and stimulate the hypothalamus. The fat tissue becomes a self-sustaining loop that manufactures the very hormone that keeps it alive, then uses that hormone to coordinate more raw materials from the immune system. Research in endocrinology has tied visceral adiposity directly to elevated cytokine levels. Studies on 11-beta-HSD1 overexpression show it is associated with localized hypercortisolism. The loop is measurable, and it operates in millions of bodies right now. Here's what happens when you deliberately add more stress to the system. That is where standard behavioral habits enter the picture. Now we arrive at the piece that rarely gets mentioned in wellness marketing. When you aggressively restrict calories, when you skip meals, run long distances, and maintain a constant deficit, your body perceives a famine. Evolutionarily, this made sense, because food was scarce and the body needed to conserve energy. The primary signal it uses to conserve energy is cortisol. Studies on caloric restriction show that sustained deficits raise baseline cortisol levels. The Minnesota starvation experiment from the 1940s documented this decades ago. Researchers fed healthy male volunteers reduced calories for weeks. The volunteers lost body weight, but they also developed metabolic adaptation and elevated stress hormones. Modern reanalysis confirms that severe restriction triggers adaptive thermogenesis, a drop in resting energy expenditure that outlasts the diet itself. When cortisol rises, it sends a signal to the liver. The liver responds by manufacturing glucose out of amino acids and other substrates through gluconeogenesis. This process means your body creates new sugar from its own tissues, even when you have not eaten carbohydrates. That newly manufactured glucose enters your bloodstream. Your pancreas detects it and releases insulin to manage it. Now you have high cortisol and high insulin simultaneously. Insulin is the master switch that locks fat stores. Cortisol is the signal to hoard visceral fat. Together they create a metabolic state where your fat stores are sealed tight, and your belly is expanding because the cortisol antennas are screaming at full volume. You are restricting food and your body is still hoarding energy. There is a specific pattern that reveals this loop is active in your body. It is the 3 a.m. wake up. Here's what happens. While you sleep, your blood sugar naturally drops. If your metabolic flexibility is compromised, if your body has become dependent on constant glucose from food, that drop happens too fast. Your brain senses a threat. It thinks it's running out of fuel. It slams the panic button. Your adrenal glands fire a shot of adrenaline and cortisol. This signal wakes your liver and tells it to dump glucose into your bloodstream. That surge is what wakes you up. You're waking up because your body just experienced a fight or flight response in the middle of REM sleep. The consequence is twofold. First, you miss deep sleep where growth hormone is released. Growth hormone is the primary antagonist to cortisol, so without it, the cortisol loop runs unchecked. Second, you spend the rest of the night bathing in cortisol and insulin. You wake up puffy and with your visceral fat storage pathways turned on high. If you're waking up between 2 and 4 a.m. regularly, your metabolism is sending a distress signal. And here's what the evidence says about stopping it. The research on cortisol and visceral fat points to a conclusion that contradicts traditional fitness advice. The evidence suggests that aggressive caloric restriction, chronic steady-state cardio, and prolonged fasting, when layered on top of a high-stress lifestyle, do not reduce visceral fat. They reinforce the hormonal signal to hoard it. The mechanism is straightforward. The body interprets the combination of stress, insufficient fuel, and high energy output as a famine. The cortisol response is an adaptive survival mechanism. It is working exactly as designed. The problem is that the famine never ends. Studies on interventions that actually reduce visceral fat show a consistent pattern. The most effective interventions are not about eating less. They are about signaling safety to the metabolism. Studies show that resistance training and high-intensity interval training, short bursts of intense effort followed by complete rest, reduce cortisol and increase growth hormone simultaneously. A meta-analysis in the British Journal of Sports Medicine confirmed dose-response effects of exercise on visceral adipose tissue in adults. The evidence on post-meal walking, 10 to 15 minutes of low-intensity movement after eating, shows it mechanically lowers blood glucose without requiring additional insulin, which reduces the storage signal. Sleep interventions that stabilize overnight blood glucose reduce the nocturnal cortisol spike. The body hoards deep belly fat when it perceives a threat, whether that threat is psychological stress, physiological stress from overtraining, or metabolic stress from undereating. The cortisol receptor density in visceral fat amplifies and sustains that threat signal. Which brings us to the verdict. Your visceral fat is not a storage problem. It is a signaling system. The standard advice, eat less and move more, ignores the hormonal layer entirely. It treats the body as a simple calorie bank when it's actually a complex biological network with survival instincts that predate agriculture. The fix is not more restriction. The fix is signaling safety. Research indicates that short, intense movement, followed by recovery, changes the hormonal profile. Post-meal walking lowers blood glucose mechanically. Stable sleep prevents the nocturnal cortisol spike, and sufficient food signals that the famine is over. The body is not broken. It's responding to the environment you gave it. Change the signal, and the physical metrics will follow.